Well, good evening, guys. Welcome to the Land Timber stream. Well, actually, we're not streaming tonight because something is very wrong with Spectrum, I think. I just checked. I've tried like 3 times to start the Twitch stream and dropping like 95% of the frames. So I finally did a speed test, and yeah, something's wrong with the upload speed right now. It's probably an issue with Spectrum. In my issues with Spectrum. I won't get into that here on the stream. I'm not going to rant about that. Rant about enough things. But at least we're going to record this and upload it whenever we have enough bandwidth to upload it. But tonight, a couple of things going on here. Let me pull up the agenda that we had and close a few of these windows, like the chat window. Won't do us any good. But there's another episode of Network Collective. I should put that here. So I haven't listened to it yet. Pretty sure that's going to be a good episode. Normally, I don't put any meat chunks here unless I can vouch for them personally, but I just have not had much time at all to listen to podcasts, watch videos, etc. I've been very busy, and I've been studying like crazy. So where I'm at right now, IPv6 is ongoing. By the way, wallpaper of the day. If you haven't seen the video yet, guys, check out the Falcon Heavy launch video. Here they are landing zone 1 and 2. I believe the 2 side booster rockets returning back to Cape Canaveral. Awesome stuff. Anyway, IPv6. Watch some more videos today. I've been downloading videos, watching videos. This time though, I've been watching the advanced technologies, which are geared more towards the lab preparation. But the written videos themselves just did not seem to have enough about IPv6 to kind of really tell me much. So I got all the way to OSPF v3. Yeah, I've done these. That was interesting. IPv6 over DMVPN, EIGRP, real simple. OSPF v3 is kind of a different animal though, so I've not finished that. But anyway, those are the videos I'm watching these days to study. And today we're going to do a lab about spanning tree root port selection because I had some problems. Again, Boson is so good about identifying my weaknesses, and I definitely have an issue on prioritizing or really understanding the spanning tree root port selection process. There's a very specific process, a very specific set of criteria that is used. And I've discovered today that really I don't have that down. So I'm going to repeat a couple of labs to do a spanning tree. Just by way of review, I've done them. I have actually not done these on this channel before. Or maybe I have. I don't think I was streaming then, and I had already done these labs. So anyway, we are going to just set this up. Probably going to be pretty quick labs. But we're going to do some requirements here. We're going to type these up and look at these criteria for. And the other thing I haven't really done much of is packet captures of BPDUs. I have not really looked at that in depth in Wireshark, so we're going to do that today too. That's going to be good. And hopefully next time this question comes up on Boson exam, I'll get it right. That's the goal. But there's the configs. And as far as topology goes, we're just using, I have a modified, let's folder back open. I have a modified copy of the topology from INE where I've actually mapped out this comes in really handy. I've mapped out the actual interfaces because topology on the INE, which is linked below, the INE drawings, use these FA023, which was probably their rack rentals. But in all the viral topology repository files, they're using these gigabit interfaces. So I've launched the basic layer 2 switching topology and killed the routers. So we just have 4 switches up and running right now, which is all we need for this lab. And these are the 4 switches, and my requirements are these, which I'm going to mention right now. By the way, this standard disclaimer, it's not a lab I designed. This is in the INE workbook, which I don't show on screen. If you want to do these labs yourselves, definitely check out the workbook, which is linked below. $2.99 before discounts. But yeah, disclaimer there. All right, configure, here's the requirements here. Configure inner switch links as 802.1q trunks. Disable all other inter switch links. Oh, between switch 1 and all other switches. Okay, links switch 1 to all other switches. So we've got switch 1, but we got switch 2 connected to switch 3s. Switch 2 to switch 4, switch 3 to switch 4. So we need to disable all those links for the purpose of this lab. And configure 802.1q trunks. Static. So disable all other inter switch links. I'm going to put this up here. And we're going to then configure VLAN 2 on all switches. Switch 4 should be the STP root bridge for VLAN 2 using lowest possible priority. If switch 4 goes down, by the way, what is the title of this? This is STP root bridge election. If switch 4 goes down, switch 1 should take over using second lowest priority. Now this is not too big of a deal here because this is just root bridge election. I think I've got this. I do want to do some packet captures of this and see what this looks like. And I think this will lead right into our next lab. But we're going to go ahead and do this. So I think what we need to do here on switch 1, do we need to disable any links? No. Let's disable the links first. And we're going to say interface range GI0. Is that right? Yeah, GI0 1 through 2 shut down. Interface range GI0 1 through 2 shut down. You really have to shut them down on both sides. You can't just rely, because these are, yeah, virtual environment. Let's make sure. So let's go up to switch 2 next. Interface range GI0 1 through 2 shut down. Interface range GI0 3 through, actually let's do GI0 1 through 3, and then interface GI1 0 shut down. Okay, that's switch 2, and then we'll go over to switch 3. And we'll say interface range GI1 0 through, is that right? Yeah. GI1 0 through 3. And then interface GI0 3. At least I think that's how this works. We're going to double check because I think this diagram is one that I did based on a topology I built. Let's see, let's check it out. Let's pull up our switches. And let's look and see what ports we're using here. 20, 22, 24, and 26. Okay. So switch 1. Switch 3 is 24. Show CDP neighbor. All right, let's see if this is right. So switch 4 is GI. Ah, this is different. No, GI 10, GI 03, right. GI 12 and GI 11. Yes. Okay, switch 3. GI 03 and GI 01. Not sure what's up with this business of the 00s. You know, I've always been curious what this looks like in via Maestro. Because these ports come up, GI00, and they're always enabled. So let's look at the physical topology of this. Make sure I understand what's happening here. Like, are they going through an unmanaged switch or what? That's how the routers are. They all connect to an unmanaged switch. Okay, we want to go to our simulation. Let's see the interfaces. So GI00, see, I'm not sure I understand. Make sure this matches. I don't want to end up doing this lab and getting frustrated. 1-1, 1-2, 1-1, 1-2. Okay, 0-3, 1-0. Okay. It's been a while. It's been a while since I worked on it. Okay, everything looks good. So why 00 is up? I have no idea. Interface chat 00, shut. Okay, that's what we want. Now, show CDP neighbor. Same thing. Okay, good. All right, those interfaces are shut down. Now we can proceed with our lab here. And these all match. So this is to basically just put switch 1 in the mix. And then let's go ahead and configure this. So we're going to do link switch to all those, disable all the interswitch links. Okay, that's good to go. Figure interswitch as static 802.1q trunks. So what that means is we can start at switch 4. Interface range, GI 10, GI 03, switch port mode trunk. Port trunk incap.1q. We might need to do that first. Okay, copy that. And then on switch 2, The interface range GI1 1 through 2. And on switch 3, it will be interface range GI0 1 through 2. And then we'd have to do it on switch 1. And we're just going to do interface range GI0 1 through 3 and GI1 0 through 2. Okay, that creates our trunk ports. Configure VLAN 2 on all switches. Okay. We have to create this VLAN. We have no VTP or anything like that. Okay, configure VLAN. Spanning tree should be the root bridge for VLAN 2 using the lowest possible priority. So I'm going to save that. Actually, no. I'm going to go ahead and start the capture. So, because I want to see the transition. I know it's going to be a lot of BP to use. But what we want to see here is from, let's do it from the perspective of router 2. And, oh man, what should we capture on? Man, I want to capture all the interfaces. That's what I'm going to do. Let's see them all. Why not? Now, I don't need to capture, hold on, 1, 0, and 0, 3. Yeah, four interfaces. I know it's a lot, but this is going to be router 2. We're going to call this router 2 BPDU. BPDUs. Yeah. Router 2, switch 2. You know what I mean. Okay. And okay, so let's do this first. Then we're going to change the priorities later. So let's do switch 4. Okay, it liked everything there. Switch 2. Switch 3. Oh, we didn't do something right here. Shoot. GI 1, 0. Ah, okay. 1, 0. GI 0, 3. Oops. Okay, let's try that again. There we go. And on switch 1. Okay, so we should have on switch 2, show VLAN brief. We have VLAN 2, show interface trunk. Okay, GI11, GI12. Now wait a second. Links with switch 1 to all other switches. Disable all other interswitch links. All right. That's okay. All right, so we should have received, the BPDUs are going to go here and then here because these interfaces are shut down. These interfaces are shut down. These interfaces are shut down, right? So everyone's going through switch 1. So the BPDUs should come here, and it should indicate that right now, let me think, who would be the lowest, the first selection, the first criterion in the election is lowest bridge priority. So right now they should all have the same bridge priority because we haven't modified them. They're the same model. Then we go to the next criteria, which should be the lowest path cost. So everyone's going to advertise their BPDUs. They should all have the same path cost. Well, no, that's where switch 1 will win because the path cost he reports. Yeah, let's look at show spanning tree root. Root cost is 4. Yeah, the root cost is going to be higher, so he'll send a BPDU and essentially switch 1 is going to decide because he's going to have the lowest path cost of any other BPDUs. These switch 4 is only going to see BPDUs from switch 1, same with switch 2, etc. So yeah, the path cost of switch 1's own BPDU is going to be better than any that it receives from his neighbors. So he will choose himself as the root and then advertise his own BPDU to the other switches. I think that's what will happen. But this would be the typical priority selection. Bridge priority, lowest path cost. Let's see, show spanning tree VLAN 2. Priority 32. See, my own is 32,770. Yeah, but the root ID is going to be switch 1. Let me think about that. What would the cost be? Let me think about this. Let me look at the capture. I'm not sure I can even justify right now why switch 1 would win this. All right, so let's look at GI11. Spanning tree, yeah. Is that a legitimate protocol to select? Source? Destination, yes. So I guess we just want to look at this destination. Yeah, okay, now some of these I should see from switch 1, and some of them I'll be generating myself. Topology change identification, okay. 943F. Okay, so who is this switch? FA16, let's see. All right, so this is me. I'm switch 2. And this is me sending my own BPDU. Now here's someone 943F. That's, I'm assuming it's going to be switch 1. Nine four three F. Show spanning tree. This bridge is a root. That's what we expect. But who is 943F? Dynamic GI11. Is that me? These are addresses I've learned. Show interface status. Show interface GI11. 943F. Okay. So that is this guy. Here. Okay, so who is 52FF? It must be 1, 2. Just not. Okay. Show interface status. Show interface GI. Okay, 52FF. All right, that's him. Get bigger. Okay, so let's look at that again. These are all coming from switch 1. Okay. So by the time I captured here, it looks like this interface had already been identified as the root port. And switch 2 is not sending any BPDUs. I believe that's what we're seeing. Oh, of course I captured this on interface GI11. Of course that would be what we see here. Okay. So we have no filters. and STP. I guess I could do STP, right? Yeah. 2FF. Yeah. Okay, so that's what we see on switch 2. And this is destination for all switches. Then we have PVST plus, all PVST switches, and the source is switch 1. And spanning tree protocol, BPDU type. Do these have BPDUs? Yes. That's just a TCN. And then we have PVST plus. And this is configuration. What is this type? BPDU type is configuration. I'm trying to compare these. This is sent to a different destination. So how are these different? This is sent to PVST plus. This is sent to spanning tree for bridges. What is different about these messages? Put these guys side by side. Okay, both say protocol spanning tree protocol. Spanning tree, BPD type configuration. Oh, this is topology change. Well, this is flagged with a topology change. Oh, originating VLAN. Oh, that's why it's PVST plus. Okay. So this has no VLAN tag. Is that after we created the VLAN that we started to see these? Native VLAN, maybe? Yeah, so probably whenever we created the VLAN 2, we started getting these. The destination changed. And we have, yeah, PVID, port VLAN ID. Okay, originating VLAN 2. All right. Okay. Makes sense. So we have a bunch of these. We do have a topology change notification here. Which of course resets the timers. BPDU type 80. And these look slightly different. Oh, this is when they have the topology change notification. That's a flag, isn't it? So there's the topology change notification, and then there's this flag on the BPDU. So we are in the midst of a topology change. And at some point that goes away. So we transition away from the topology change, right? The timer runs out, I'm assuming. And then we just have these. So everything starts to settle. So that's 1, 1. Still don't know the difference why we have these. Why do we need these? Because we have PBST plus. That must be for backwards compatibility or something. It's still sending those even though it knows we're running PBST plus. Maybe, for example, if we're running ISL, it's still going to send these without a, that's the only thing I can think of here. Why it's sending both. And I did not want you to close. Okay, so switch 2 starts hearing these BPDUs. And does not send any. In fact, if we look at the status, show spanning tree. So he has a root port and an alternate port, which he's blocking. So he's not going to send BPDUs, right? Because he is not the root. Now he would send it if I open it, if this port were opened. It's shut right now, but he would send, these would be designated ports, and he would flood BPDUs out this way, right? Okay. So now what we're going to do is make a change. Yeah, let's change our packet capture here too. And let's create a new one where we're going to transition. We're going to say switch to, same switch. And we really only need to look at 1.1 and 1.2. And we're going to transition switch 4 to a higher priority. Switch 4 prior becomes. Yeah, I've never really looked at those BPDUs to that detail. Yeah, so really, switch 2 received BPDUs on both 1.1 and 1.2, right? Let's just look at these real quick. And of course, we know that so he's receiving BPDs from links. Where's my notes here? Yeah, the bridge priority is going to be the same. The path cost is going to be the same. Then we go to lowest port priority, I believe. Then lowest port number. So switch 2 receives these, and this is, I think what I was doing is confusing these processes. There's a root port selection and there's a root bridge selection process. And in the root bridge selection process, switch 2 comes up, he generates his own BPDU, but he's going to receive a superior BPDU in this root bridge selection process, which goes by the way, this is the bridge ID here. The bridge ID, which is a combination of the priority and something else. Yeah, show spanning tree. Yeah, I need to look it up, guys. I've tried to go this far without looking it up, but let's look it up. Let's go to Cisco support and products, switches. Wait a second. I don't like that other menu. I guess the same. All product categories, gonna go switches. This is new too. This flat model. Anyway, let's go just good old 2960. Pick one. Documentation, configuration guides. And let's see here. Bulletin kit. This is okay. Switch command reference, feature configuration guides. Where do we find this stuff? Software configuration guide. Okay, let's go to the 3750X. I'm used to going there. And we'll go, it doesn't matter. 48PL, that's fine. Okay, configuration guides. Software configuration guide. 15, we'll go with this, it's fine. Okay, configuring. Spanning tree. Okay, bridge ID, device priority. Yeah. Unique bridge identity, the bridge ID, which controls the selection of the root switch, because each VLAN is considered a different logical bridge. Different for each configured VLAN, right. Switch supports spanning tree extensions. How switch becomes a root spanning tree to switch A is because the switch priority of all the switches is the default. The lowest MAC address. How switch or port becomes, see, they mix these two under the same subheading. How switch or port becomes a root switch or root port. Aren't those two different processes? I have no idea what. Don't you love this? Related task, configuring the root switch. And configuring the root switch. And they go to different places. Kill me, Cisco. Okay, information about spanning tree protocol. How the switch or port becomes a root switch or root port. Oh, love it. Being sarcastic here. This is the most sparse. Pretty much useless. All right, we're going to Google. Yep, Google takes me back to the same useless. Hey, Astorino Networks. I bet this is good. The bridge with the lowest bridge ID is selected. Is switch priority and a MAC address. Okay. The bridge ID. Thank you, Joe Astorino. And MAC address. So the bridge here, for example, show here's a bridge ID. Is this. And if we look here, okay. So between these two, this MAC address is going to be lower. So that's how we elect a root bridge, and then each non-root bridge selects a root port. And that is based on, so let's go back to our notes here. Lowest bridge ID. So this is lowest priority MAC address. So they all have the same priority, but we're about to change that. Then each non-root bridge root port selection process. Path cost, right. That is the first priority. So if I receive two BPDUs to the root, which one has the lowest cost? So if we look here, how do I see show spanning tree path cost? Oh, let's do that here. Show spanning tree. Show spanning tree interface. Cost is 4. That's right. Okay, I'm trying to remember now. Gigabit is 4. 10 gig is 1. Fast Ethernet is, I can't remember. $19. Yeah. Shoot, man, this is thawing out this part of the brain here. All right, the root port is the bridge close to the port selected by the lowest path. Okay. 1, 4, 19, etc. After that, the lowest port is the root port is selected. There's a tie here for switch 2. Bridge ID, lowest bridge ID of the neighbor. Okay. Beyond that, it is lowest port priority. And after that, I think it goes to lowest port number. Okay. All right. I think I got it. I always say that, but okay. So let's change it up here. We're going to change the root bridge election, in this case by modifying the priority. So spanning tree, and just for VLAN 2. And what is the requirement? Using the lowest possible priority, which should be 4096. 0. I didn't know I could use 0. Spanning tree, VLAN 2, priority 4096, right? Yeah. Okay. So now we should have some interesting show spanning tree VLAN 2 root. The root ID is, notice the root cost is 8. Root port is here. Here it should be 4. Yeah, 4. 5E0000D000. That is the root ID. Show spanning tree. Yep, that is me. Notice it does not show spanning tree VLAN 2 root. Can I see the cost detail? What is a bridge ID? Do I see the bridge ID? No, because, well, I should see it here. There's the bridge ID. This is mine. Priority 2. Oh, it adds 2 for the VLAN. So it doesn't tell me straight out what the bridge ID. It just has a root ID. So that's 2. Okay. Here it explains why it's 4098. Root ID priority number. So it's 2-5E0000D00. Okay, that's the bridge ID. All right, I think we got it. So now let's move on. Thank you, Joe Astorino. Let's stop the capture and see the transition here. Yes, we're gonna have a lot of BPDUs in here, but that's okay. Okay, and we will take a look. What I'm curious to see is the BPDUs that come from switch 1 after we have the change. So first of all, we should see a TCN. Yeah, it's going to be way down here. Okay, topology change. So prior to that, we're receiving BPDUs every 2 seconds. Root path 5E, that is switch 1, I believe. Should be. VLAN 1 should show that, yeah. A versus D, right. and bridge root identifier and root path cost is 0. Bridge identifier is me, the same. Port identifier 8006, originate VLAN 2. Okay, then we have a topology change. And this is not a topology change notification. This is actually a new BPDU with the topology change flag set. And what he's saying is, hey, look, we got to put topology change. This is the new root identifier. Root path cost is 4 for me. And this is me. I'm the bridge identifier. Okay, so in our root path, let's say switch 2 was getting lowest, this is wrong, lowest path cost. Which makes sense. That makes a lot of sense that that's what we should use. But if I had equal cost paths to 2 different switches, I'd go with the bridge ID of the neighbor sending it to me. Okay, makes sense. All right, so that's our change. And the TC is set for a little while. And then we go back to normal. Now we got these PBST plus, yeah, for VLAN 2 and 1. Notice 1, of course, is the same. Now, on our BPDUs for VLAN 1, we should not have a topology change flag. We don't. Good stuff. Okay, so that is holding up. So now let's go to our next little lab here. And yeah, configuration is correct. Port cost. Okay, so in this case, we want to ensure, now let's set this back. Apparently need to change the priorities back. Spanning tree, let's see, no spanning tree, VLAN 2 priority 0. That will set it back to the default. No spanning tree, VLAN 2 priority 4096. Okay, and these are the new requirements here. VPath selection with port cost. All active VLANs from switch 2. Ah, this is a different topology. Okay. All right, that's fine. We will stop the simulation. Good stuff, though. Very good stuff. All right. All active VLANs from switch 2 to switch 1 uses, it says FA020. All active VLANs from switch 2 to switch 1 use FA020. Link between switch 2 and switch 4. Okay. All active VLANs from switch 2 to switch 1. Ensure that traffic for all active VLANs. Okay, so in this new viral topology, we're going to assume that all these ports are up. And what we want to do is establish so we're going to get BPDs from switch 1. And we're going to get BPDs from switch 4 and switch 3. But we want to have it use the link, prioritize a link, prioritize GI02 if goes down GI01. Okay, so if we look back at our, yeah, the lowest path cost, right? So by default, the path cost here will be 4 and 4 on these links. The path cost here will be 4 and 8. So I think what we want to do is make the path cost here be, there's a couple ways to do this, right? But I think what we could do is say interface GI02 spanning tree path cost. Is it, can we make it 1? And then interface GI01, we can make this 2. I guess for good measure, we could also do interface GI0, GI interface range 1, 1 through 2, and bump this way up, right? You know, just for to be thorough. All right, let's pop open this. Let's pop open a can of, not whoop ass, but a spanning tree here. This is LAN switching initial spanning tree. Okay. I don't know why there's a backup there, but okay. We'll wait for this to launch. Yeah, I think that's all we need to do there. And then let's go ahead and look at the next one with port priority. This is going to be lab 1. Then lab 2. Using spanning tree priority. That says port priority, which will be the, yeah. This we can manipulate, right? And this we can manipulate. I don't know, can you really manipulate the bridge ID? Yes, because you can manipulate the priority. So we already basically did this lab in essence. And that would be hard to replicate in this topology with only 4 switches. Not really. We could shut down all these links and then make switch 3 the root, so that switch 2 would receive VPDs from switch 1 and switch 4. And we can make this 0, and we can make this 4096 and this 8192. And it would go with the lowest bridge ID of the neighbor. That's how we could simulate that. But that's not in the INE Lab workbook, and we're just going to do lowest port priority. So in this case, same scenario using port priority. So in that case, we would do, let's see how our, in this case, we can make this now. What? Let's see. Ports priority of 1. Essentially the same thing. I don't know what increments we're allowed to use here, but that's essentially what we would do. Okay. All right, these guys are coming up. I'm going to shut these routers down. One of these days, I'm just going to take the time to build the switching topology without all these routers in here. I think I have done that, actually. Okay, these switches take a little bit to come up. That's chugging a little bit. They'll come up with it when they're ready. These are still building, terminating. Yeah. Does it have the... Let's look at what we saw before for the port priority and the path. We already know the path cost. I remember the path cost. It was 4 and 8, respectively. But port priority on these BPDUs, let's look down at 1. Let's look at a PVST one. So if you look at this, the route path cost, bridge identifier says 3270 and the MAC address. Bridge priority, blah, blah, blah. Port identifier. This is 8006. Yeah, so that's a local value, right? Locally significant value. We're not going to see that in BPDU. Wait for these switches to come up. Have you guys, if you gals haven't seen the launch yet from yesterday, definitely check it out. The SpaceX Falcon 9 Heavy. Must see. I watched it a couple times. And Starman, supposedly we lost contact with him. He was off course anyway, but got our last photos of him. Elon Musk, interesting to follow on Twitter. Hey, we're okay. All right, so switch to... so if I look at show spanning tree, root ID is 4097. FE, yeah, it's going to be switch 1. And priority number 128.1, 2, 3, 4, 5, 6, 7. Okay. And then the cost Okay, let's shut down GI00. We don't need that. Oh man, I do that every time. Something about this script that borrow topologies. Okay, so on this switch, let's venture into this first one here and see if it lets me make this change. No, spanning tree cost. One to okay. So it's just spanning tree cost. Make this 2. And we're going to change this as well to 19. Okay, so now show spanning tree. All right, notice we're in listening. We actually caught it in listening mode. GI02, that's what we wanted, right? Yeah, prioritize GI02. Learning, listening, learning. Everybody else is blocking. And 40. Yep, this is our root. Good deal. So now let's remove that. We're going to say no, no. Okay, so this is transition now, GI11 back to, okay, right. And the reason is because of cost. Cost is going to be lower. It's only going to be 4 here. Calculated cost, not statically configured cost. Okay, so now port priority. This should be interesting because it has a priority and then a number. I forget how this works. It's been a while. So let's say interface GI02, spanning tree, port priority. Port priority in increments of 32. Okay. So we'll say, can we do 0? Yes. So we'll make this 32. And we'll make these the default. Well, let's set them statically. We always want to set them. 120 plus 32 is 160, right? Let's try that. Show spanning tree. Okay. Now these are all forwarding. Designated. They're designated. Yeah, look what it did, 0.3. This would be the interface number, maybe? 2, 3, 4, 5, 6, 7. Maybe that's what that is. Show spanning tree. Interface GI02. Priority and number. Port identifier. How is this calculated? Interesting. Port path cost is 4. Port priority is 0. Port identifier is 0.3. Kind of tells you right there what the order is, with the exception of, wait, it's alternate blocking. Is that right? Port 3. Interesting. That's why it's 0.3. Port 3. No, this should be forwarding. This should be root port. 1.1 is a root port. Oh, we have to kind of leverage. We have to leverage the cost as well. The cost is the same. How could that be? Oh, the cost of the interface. That can be misleading. The cost of the BPDU here is going to be so we have to bump this cost up. Interface range, GI1, 1 through 2, spanning tree, cost. Yeah, we have to make this higher. Let's say it's 19. We want the decision to come down to port priority. But to do that, we still have to influence the traffic going this way. We have to do the same here, right? Let's see. Interface range 1.0 and GI 0.3. Spanning tree cost will also be 19. Yeah. Now these two have a lower cost. Then it should come down to they're going to have the same neighboring bridge ID. But this should have a higher port priority, or the lower port priority. Oh, it must go by the higher number. Is it the highest port priority? Let's see. Let's go back here and change. Or maybe that's why I was choosing these. Okay, the lowest path cost should automatically choose switch 1. Lowest bridge ID of the neighbor. That's if there's a tie here. We created a tie with 2 ports going to switch 4, so this is not a factor. Then it should, I put lowest, it must be highest port priority. Let's change it. Let's make, so this should be 0, really. And 0.2 should be 160. And let's make this 32. Let's do it like that. GI01 is still selected. I'm going to look at the lab key here. So this is saying FA019, configure port priority. No, it is lower. It's lower. But that's not what I'm seeing here, so. GI01. Yeah, right now it has the lowest priority, so let's change it back. 02 should be preferred. 0. This says it can go in increments of 16. So let's do that. Nah, 32. Interesting. Yeah, the lab key was showing 16. Must be a different. Okay, show spanning tree. The 02 has the better priority. Still choosing that one though. GI01. Yeah, why is that? That's wrong. Let me shut them both down. Still said GI01. Let's see. Show spanning tree, VLAN 10 detail. Current root has priority 4097. Root port is 2. Cost of root path is 8. Designated bridge has priority 8193. Port identifier 32.2. Let's look. Show CDP neighbor. Which 4? Yeah. And then let's look at 2 detail. Port priority is 0. Port path cost is 4. Port identifier. Designated bridge port address. Yes. Designated port ID is 128.3. Designated path cost is 4. So why is it choosing this port? He has the better port priority. Zero dot 3. Show run interface GI01. Show run interface GI02. There it is, folks. I don't get it. Don't get it, but my configuration is correct, and the whole point of this is to review this because I kept getting this wrong. I get this wrong a couple of times in Boson that I've been testing on it. Hopefully now with this one and the EIGRP one I did yesterday, I will have this down. So that's the goal here. I think I remember seeing this problem when I did this lab before. I could probably go back and look at the video and see, but anyway, that's going to wrap it up for tonight. Hopefully tomorrow my upload speed will be reasonable and I won't lose 90% of packets, 95% of packets. And I'll be able to broadcast it live. Otherwise, you'll see it on YouTube like I'm going to upload this one tonight. And happy labbing, folks. Happy learning. Hope you get all the good bits. And we'll see you back here soon in the Land Tamer stream.